Hi, teacher me.
Hi, Kevin.
I love it. It's so funny.
I love it. It is so funny. You said it so funny. It is so funny.
I love it.
The time of my life.
I love it. It is so funny.
That's the whole room laughing.
I'm shaking in my
Alright, so we hit started with this problem. I know somebody in here had solved it and they're like freaking out. You're like, oh my god, I got that right.
Oh, that was me. I freaked out. I'm get out.
That doesn't help me.
Great, stop everything, quiz now.
He said he was good at it, not all of us.
Oh, that was me. I
So
did.
in this, we had talked about when we're trying to determine if something's moving or not, you have to overcome that static friction force.
You have.
So if we overcome that,
A pencil?
I don't know that with
Yes, you may. So we need to solve for it and see what we gotta get. So the first thing we gotta do is whenever you're trying to find the force of friction, we're gonna need the normal force. So in order to get that, the normal force is equal to the opposite force of gravity. So
That looks
mass,
like
88 kilograms,
88
times the negative 9.81 meters per second squared. I just kept that negative because y'all probably gonna want negative. I got this negative here in the front, so I gotta throw that. Negative times the negative equals positive. So I'm gonna make those positives.
fancy.
Fancy.
Français.
So 863.28 newtons. Is what I get.
Correct.
Then we multiply that by the coefficient of
Static friction. So we're trying to find the force of static friction, which is less than or equal to the coefficient of static friction, which we have is 0.21. Remember, there's not units on the coefficients. Times 863.28 newtons. Which, whenever you do that, you will find it to be
81.288. What? I don't know if I left something out.
181.28888.
Hey,
No,
No, we went 3 8.
Eight.
hey.
Hey, hey.
Hey.
So-
Would you look upon yeah.
That's what the force.
You ruined it.
That's what the force of static friction is. And here's where I said you guys have to think in depth.
You have to think.
Oh my
In
God.
order for us to be able to move the fridge, yes?
What do you
When
want?
you said we have to think, I thought about the Bee movie. It's like thinking bee, thinking bee, thinking bee. You know when they're like landing the airplane?
Yeah, I never watched that.
Yeah.
Bee.
You've never watched it? Is that what you just said?
Bee.
Yes, I feel like
She's
you're so
now
offended. You look like
offended.
a
I am
sister
very
whenever I
offended.
told her I never watched Frozen.
Okay,
You're not
Frozen
missing
I can
anything.
understand.
Yeah.
Or
But
Frozen.
Bee
You're not
movie
missing
is
anything.
it's a classic.
Megan
I
Brown.
like
It's
begging
like
you to
all
go
of
home.
us is Jones.
Please go watch it when you get home. I'm telling you, you will not regret it a single bit.
What's
It
it
is
called?
hilarious. I watch it almost at least
What?
once a month.
I'll take this under advisement.
You've never watched it either?
So in
I
this,
just thought it was funny.
the force being pushed, we have to push with a force greater
Jerry
than
Seinfeld. is like-
181.288 newtons. Now, why do we have to push with a force greater than that? Because if we push with that, these would cancel out and equal to a net force of 0, which is not what we need. We need a net force of...
What was 2 eating?
What?
Really?
You can rate that?
Yeah.
What is it?
I'm not blind. My glasses.
Help us.
Hey, look at what was
Shoving out the door.
what was 2 eating? 2888. What was he eating?
Yeah.
8.
No, he was
2
8
8
and 8
8. 2 8 and 8.
and 8.
Eight,
What-
eight,
what was-
eight,
He ate
He ain't
Newtons.
doing
eight, and eight, and eight, and eight.
Big Newtons.
Alright. This is where I want to make sure you guys get understanding there on number 72. You guys have questions.
Is that all we
Okay.
gotta do? For that?
So we
Yeah,
all
that's
like,
literally it. But this is where one of these problems, and if you guys start catching on to me. Where I only got 45 minutes with y'all. I like to give y'all like one problem that you're going to have to do a lot of calculations and stuff on, but then other problems just to have you some points on there. I like to give you stuff to where you have to think.
THA.
That's right.
So would this be, so say, would
So
this be
this-
like a one, like a,
Okay, so which is the one that we don't have any units on?
What's the 14th?
Those are the
The
coefficients.
Okay.
this would be like a one
What's the
step
point?
to a problem that you would give us, like,
I
right?
keep writing equal, but it's not equal.
Very much.
Okay.
Because it's just a lot of thinking. I mean, literally, like, I think we're getting to the point, ain't none of y'all going to sit and write all this out.
No.
You're just
No.
going to punch that in the calculator real fast. You're going to be like, oh, normal force is opposite of that. So you just throw in mass and 9.81 in the calculator and you get that. And you're just going to throw it in. I mean, you're
Is
getting to
that-
that point. I don't expect you to write down every little mathematical thing you're doing, but like stuff like this right here.
Do you
I
have to
expect it.
find the normal force?
Yeah,
So,
kinda.
questions on 72?
So if you have to find the normal.
Let's do another one.
Normal force and force of gravity is the same thing, just opposite side.
Yeah.
So the force is static friction.
They're equal to each other,
Until
opposite in
we put it on
direction.
ramp.
And,
Yeah.
we don't need those.
Apparently I'm safe to say that.
Okay,
It's not in.
what's the new S?
Mm.
Just static.
Exactly.
That's the coefficient of static friction.
The coefficient of static. Okay, so static friction is less than or equal to the coefficient of static friction times the normal force.
Yes.
Okay. I was just getting that.
The force of normal.
Okay, here we go.
I was retaining information. I retain information when I was talking out loud.
Alright, so 73.
That knuckle.
Now you got him self-conscious.
Nuh-uh.
I did earlier.
He's gonna have to wear gloves now, Matt. Just because you said that.
He wears like the fingerless gloves. like writers.
Alright, 73, you're driving a car of 1,200 kilograms. So we have a mass of 1,200 kilograms. At a constant speed of 14.0 meters per second, so we have a velocity that's equal to 14.0 meters per second. You know I'm already liking this problem because out of nowhere we're getting stuff for motion and we're dealing with forces.
Yay.
Show you force.
Along a straight level road as you approach an intersection, the traffic light turns red. You slam on the brakes. Car's wheels lock. The tires begin skidding and the car slides to a halt in a distance of 25 meters. In this case,
That's final.
delta X, or you can do X final, that's fine.
Oh God. Not Delta.
Yeah, can we use X final? Because I think delta X and I think.
Yeah, I like good.
Calculus.
Why out? And then I
I'm not whiting that out. Make an X final on your paper. I'm just saying to change the position.
But right out. Future me, that delta X is X final.
It's not
High
calculus.
X final.
Oh,
Yeah. I was working it out.
Yeah!
Hallelujah. Crybabies. So what is the coefficient of friction, of kinetic friction between your tires and the road?
A
So
number, at least. Greater.
we're trying to find that. In this case,
UK.
we know
UK has a lot of secrets. So there's a bunch of question marks.
what pieces of information have you been given? So
Okay, so
mass?
we have X final. We have velocity. Is
A
that
velocity.
what are these
initial.
related to in terms of
That's
physics?
velocity initial.
Motion.
Motion. So we have motion stuff, but we're trying to find force stuff. How do we relate motion and forces?
Mass.
Through acceleration.
Through
Acceleration.
acceleration.
Mass and acceleration. Beautiful job. So in this, what we're going to need to find?
Acceleration.
Yeah.
Acceleration. Now this is the key. We got to find that acceleration. In this, we're going to write down everything we got. What's up?
I see the formula in my head that we're going to use, I think.
Let's get
I
shopping.
remember exactly.
Velocity.
Okay, let's get a recipe down so we can start shopping. So we're gonna do x initial, x final, initial velocity, final velocity, acceleration, and time. I'm just dealing with motion right now.
Oh, we don't have time.
So in this, do we have an initial velocity? I mean initial
Yes.
position.
Yeah, 0.
Okay, so y'all wanna make that 0.
Yeah.
What about final?
25.
meters.
Beautiful job. About
Yep.
initial velocity.
14.
Yeah.
Meters per second, because that's what we're
0.
starting with.
Velocity
about
final?
final?
0.
Oh wow.
Because the
Could
car stopped.
well, that's what I was saying. Is it purely situational, or could that
So-
be?
We're trying to find this.
Hold on.
this
Wait. Okay, I can't do this. I cannot do 2 questions at the same time. It's going to be different.
Is it according to situation within the problem, whether or not, like in this case, you're starting off with 14 meters per second and then you're ending? Could the 14 meters still technically be velocity final, or is it not interchangeable at this point?
You could do it in velocity final, but then you're going to have to do something I didn't like doing. In
Okay.
college, we worked backwards.
Okay.
I didn't like it.
So we're talking
You can do
from the point you started to stop until you actually stop, because we're trying to find the kinetic friction as he's like skidding, right?
Yeah.
So if you're going 14 meters per second, but you start to stop, you're going less than 14 meters per second as you skid.
Correct, which is why your
Which is
acceleration
what
becomes
happens
negative.
from when you were 14 at the moment where he first touches and applies the brakes until he stops. So we're finding the acceleration for those 2 times.
Acceleration is going to be negative.
Okay.
You're looking over a span of time. Acceleration?
Why would acceleration be negative?
Because it's acting
Because you're
against.
slowing down.
We don't know. Time?
You're
Nope.
slowing down.
No.
Oh boy, what are we going to do?
S
Velocity
S
final
equals D over
squared.
T. Just kidding.
Velocity final squared
Equals
equals
velocity
velocity
initial.
initial
Yeah, I got you.
squared plus 2
So
times velocity.
It's 2A.
final. I mean x
A.
final.
A.
2A times.
the quantity of x final minus
Final
x
minus
initial.
x initial.
Or change in time.
Delta x,
Speed.
whatever
That's not
it
change
is.
that's change.
Alright, so, gotta get acceleration by itself.
It's not time.
Oh, change in position. Same thing. You know what I was talking about.
I did, but I was so confused. That
No, you weren't. You were just correcting.
Yeah.
Alright, so you do some algebra and get to that. Acceleration is equal to velocity final squared minus the velocity initial squared quantity, all divided by the quantity of 2 times
math.
final position minus initial position.
What? What
When
did
you
Connor
said-
just yell out? Math.
Yes.
Did we get
Do I get a plaque?
Oh my god.
I'm really
Do I get my name on the Hall of Fame?
Bring the clock back.
There's a 3.92.
I really have PTSD.
Negative
I was
3.92.
Oh, no. So, okay,
Meters
so
per
we got velocity final,
Okay.
14 meters per second, minus initial, hold on, I'm getting backwards here. Okay, I do need white out now.
We need
It's the
white
same
out.
thing, just make it negative.
Yeah, because I'm quick.
Didn't mean the same.
I know, but then y'all gonna be
Mean the same.
like,
What'd you say?
I'm confused. What do I do?
I really want to know after you're done.
0 meters per second minus 14 meters per
How can you
second
write over it like that? I've never been able to-
divided by
And I was just
2
like,
times
What did you
25 meters
I was
minus
thinking.
0
I'll
meters.
tell you in a minute.
Should be equal to
Mr. Hall, what happened to your squares?
He's
Good
not done
catch.
yet.
Oh goodness.
3.92.
That's exactly what happened. I got so frustrated because somebody made me have to stop the video.
I wonder who that
Why
somebody
is
could
that
be. Where's Gerald?
Because
squared?
Yeah.
velocity final squared, it's just in the equation.
Oh,
0 meters per second.
It's still
Okay,
zero.
2. And I get negative 3.92 meters per second squared.
I got negative 179.
And then we
Would you type in your calculator?
Negative 14 divided by 25.
That's probably unit squared.
That would be negative 14 squared.
14
Nice.
meters per second squared.
Right there's what you're looking at. That's what I put in.
Why'd you put it to the other thing?
Because I separate my numerators. and
Can you
denominators.
move that real quick?
Why are they all in parentheses?
Because I love to use parentheses because I know the calculator will read what I'm trying to tell it to read properly, so I'd never have to worry about, oh, did I punch that incorrectly?
Yeah, now I got.
All right.
Wait. If you're dividing meters per second by meters, what would that still would be meters per second squared?
1/2.
Well, in this case, wouldn't it technically it would keep the
You get meters squared over seconds squared divided by meters.
Meters.
What?
It'd be meters.
Meter,
So
meters.
meters squared over
Meter,
seconds
meter.
squared, why?
Well,
Okay, right here.
Yeah.
That squared will square that and square that. So you will have meters squared divided by seconds squared. You got meters on the bottom, so you divide it by meters.
and you
Which
flip
is
it
the
up on
same
the
as
bottom.
meters squared over seconds squared
That's 5.
times 1 over meters.
And the meter will cancel.
To leave you with meters per second squared.
This isn't fair.
Wow.
Okay, so we got that. Now we're looking at what's this acceleration being used for. It's the force that's literally pushing the car backwards. Right?
So
It's like the hand of God just came down. on
Alright,
the
this
car.
is the question for you. What force is acting in the X direction?
X direction would be. Wait. What?
Oh,
Say it again.
What's happening in the X direction?
you just multiply.
Something's having to stop the car, right? So what's stopping it?
Friction.
Kinetic friction. Force of kinetic friction.
Beautiful job. So your net force in the X direction is just force of kinetic friction.
Because there's no force applied.
Yeah, that is the force being applied, is that friction. That's
The brakes.
it.
The
And
brake.
it's kinetic because it's moving.
Yes, it's in motion.
Okay.
This is the thing, and this is a good time to explain to you. So how many of you know about cars having anti-lock braking systems?
Yeah.
No.
No.
I'm
The
sorry.
purpose behind the anti-lock braking systems
Oh.
is if you lock up the brakes, you've locked up the wheels. So then you're skidding, but you're moving across the pavement, right? At that point on your tire is sliding, so you're dealing with kinetic friction. So it's going to take longer to stop the car. Why do cars come out with anti-lock braking systems now? They won't allow it to break up. So if you try to slam on your brakes, and your brakes are going to lock up, and you're wondering why your brakes go, and it's like a jerking back and forth, they're not allowing it to lock up, because what will happen, it allows the point on the tire to move around, so the force of friction between the tire and the road is static friction.
Oh.
So it takes less time for you to stop.
I feel like I learned so much in here. Not just physics, but like life lessons.
This is what it really should be.
Can we learn taxes?
Please.
No.
The physics of my pen moving across the paper as a.
You just
That's
told
how I commit
YouTube-
tax fraud.
You just told YouTube that you wouldn't better the youth on their taxes.
Yeah.
Yes.
Because we have no clue what
How many
taxes are.
subscribers do you have? All of
You meaning
75.
what I think you were meaning?
No.
I
You
was actually
saying that?
serious about that. I
You
didn't take
saying
that
that
into
made me
context with
think
the
of
other
that.
thing.
What?
We'll address it. We will address it later. Just shut up, Maddie.
No, wait, I wanna
what's
know.
going
We will
on.
address it later. The
Put it
point of
up.
later is you
Put it
will.
up.
So in this,
Make 'em
trying to
stop
find this force, you have the mass of 1,200 kilograms
Times.
and an acceleration
Oh,
of
I got
negative
you. I got
3.92
you.
meters per second squared. So do some math.
Wait, hold on. Never mind.
Promise, follow.
Negative 4,704 newtons. That's the force. So that's the force of kinetic friction. I'm not trying to find the force of kinetic friction. I'm trying to find the coefficient.
So you take that number, divide it by, I don't know.
Take that,
Question to you.
take that number and divide it by the normal force.
Yeah.
Beautiful job. Why? Because the
Because
force
Because
of kinetic friction is equal
equals
to
the
the kinetic
coefficient of
friction coefficient
yeah.
times the normal force. So
Connor
the
started
normal force
mumbling and then said, yeah.
is mass, which is 1,200 kilograms, times
We can't see.
9.81
There you go.
meters per second squared,
It's not a pin.
which will be equal to
What?
11,772 newtons.
Sounds like a pan dog.
So now in this, I can now find that the coefficient of kinetic friction is equal to the force of kinetic friction divided by the normal force, which will be equal to,
Negative 4,704 newtons.
but do I need the negative?
No, because it's always positive.
The coefficient's always positive, so I'm going to negate the negatives, which is why I didn't worry about a negative right there.
0.3996.
So 4,704 newtons divided by 11,772 newtons. Check that out. Newtons cancel. Does that make sense?
Yeah.
Because the coefficients don't have units. So 4,704 divided by answer, I get 0.
Oh, hold on.
3996. What's the units?
Nothing.
Nice job. Boom.
Hey, what if we put in, but then said it stands for nothing?
N stands for Newton.
Well, maybe an
Yeah.
A
nothing.
lowercase n.
All right,
You
questions
can
here.
make units, we can make units.
Yeah.
Science.
What are you doing?